Okay, so welcome to today's lesson. For those with questions, you are welcome to just unmute yourself and then you can ask, okay, if I explain anything that you want to understand. Okay, so let's start. So the first question here is question number 14. They're saying calcium sulfate given by this chemical formula, okay, is a white crystalline powder, okay. And then they're saying gypsum is a mineral or a natural substance that is a hydrate of calcium sulfate. So it means to this calcium sulfate, they're just adding water. That's what it means to be a what? A hydrate. Okay, so now they're saying a 1 gram sample, okay, of gypsum contains 0.791 grams of calcium what? Calcium sulfate. Okay, and then the questions comes now. So how many moles of calcium sulfate are there in this sample? Okay, so remember they say this gypsum guy is just a hydrate of what? Calcium sulfate. So to the calcium sulfate, we are just adding what? Water. Okay, so to this sample, the 1 gram sample of gypsum, they are saying it contains 0.791 grams of calcium sulfate. And then they want us to find the moles of that calcium sulfate. So what are we going to do? So we know the formula, right? So let me write it here. So we know that moles, okay, are just equals to what? The mass over the what? The molar mass. Okay, so this molar mass, where do you get it? You get it from the periodic table. Okay, so what is the mass of the calcium sulfate, okay, in the gypsum what? Sample. Okay, so we are told that the mass of this guy, okay, is equals to this. So I'm going to write mass. Okay, so we are told the mass of this guy in this sample, it is what? 0.791 grams. Okay, so for us to find the moles of this calcium sulfate, we need to find the molar mass. Okay, so the molar mass, we just get the individual molar masses for all these elements that are in this calcium sulfate, and then we add them together. That will be our molar mass. Okay, so molar mass, I'll just write MM for calcium sulfate. Okay, so you get these numbers from the periodic table. So what is the molar mass of calcium? Okay, so you should check your periodic table, but it is approximately, is it 40? Yeah, 40.08 grams, somewhere there. Okay, so for the calcium, we're saying it's 40.08, okay, grams per mole. This is the molar mass of calcium. And then for the sulfur, according to the periodic table, is 32.07 grams per mole. Okay, and then oxygen, we know that oxygen is what? 16. So 16 grams per mole. Okay, but in this formula, we have 4 oxygens. So it means this oxygen and then a 4 down there, we are going to multiply 4 multiplied by the 16. Okay, so this is going to give us a 64 grams per mole. Okay, so for us to find the molar mass of this whole compound here, we are going to add this plus the 64. Okay, so when we add this on your calculator, what are you going to get? So molar mass of calcium sulfate. So just punch those values on your calculator to see what you're going to get. Okay, so let me punch them on mine. So I'm adding 40. This should be 08, not 80. Okay, so 40.08 plus 32.07 plus 64. Okay, I'm getting a 136.15 grams per what? Per mole. So this one here is my molar mass. Okay, so since I have the molar mass now, and I also have the mass here, okay, I can use these two to find the what? The moles of calcium sulfate. Okay, so let's find the moles. So the moles of calcium sulfate, let me write it here, just equals to the mass, which was 0.791 719 divided by the molar mass, which is this guy here. Okay, someone has their mic and mute. Feedback. Or maybe they're asking a question. Okay, so let's divide by this 136. So 136.15. Okay, so punch this value on your calculator. What are you going to get? Okay, so when I punch this, I'm getting approximately 0.00581 moles. Okay, so these are moles of what? Calcium sulfate. So we've answered the first question there. So any question there? Okay, no question. We'll move on to the next question. They're saying that assuming that the rest of the sample is water, okay, so assuming that the rest of the sample of this 1 gram is water, how many moles of water are there in the sample? Okay, so it means here again we have to find the mass of the water and the molar mass of the what? The water, and then we can find the moles. So remember, this sample is 1 gram, and then out of that 1 gram, 0.719 gram is calcium sulfate. So it means the remaining is what? Is water. So how are we going to find the mass of water? We are going to subtract 1 minus 0.719. Okay, so here we are going to say mass of water, okay, H2O. Mass of H2O will just be equals to the mass of the sample minus the mass of the what? The calcium sulfate. So punch this into your calculator, we are getting 0.209 grams. So this is the mass of water. And then what is the molar mass of water? Okay, so the molar mass of water is very simple. It's just 18, right? We know that it's 18. Okay, so molar mass of water is 18, or some, to be precise, they say 18.02. Okay, so you just add 2 of the hydrogens. So hydrogen, what is the molar mass? It is 1.01. Okay, and then plus the molar mass of oxygen, it is what? 16. So when you add this, you get the molar mass to be 18.02. Okay, grams per mole. So this is the molar mass of water, and then we have its mass. So meaning we can find the moles. So we're going to say moles is equals to the mass of water, okay, divided by the molar mass, which is 18.02. So this is equals to, okay, so 0.209 divided by 18.02. So according to my calculator, I'm finding 0.0116 moles. Okay, so these are the moles of what? H2O, or moles of water. So any questions on how we're finding the moles of water? Okay, no question. I'll move to the next question, which was, what was the question now? So they are saying, give the actual formula of the hydrate. Okay, so this hydrate, this gypsum, give its actual formula of the form calcium sulfate and then .x H2O. So for us to give the actual formula, we just have to find this value of x here. Okay, so how do we find that value of x? So this is how you find it. So we have this formula, calcium sulfate, okay, .x H2O. Okay, whenever a formula is written like this in chemistry, just know that it's a hydrate. It's a compound, then you are adding water to it, so it becomes a hydrate. So how can we find the value of this x? That would be the actual formula. Okay, so the value of that x is found by dividing the moles of water by the moles of the what? Calcium sulfate. So we are going to say x is equals to the moles, okay, of water, which is H2O, divided by the moles of calcium sulfate. Okay, so this is going to be equals to what were the moles of water that we found. Okay, the moles of water we found, they were 0.0116 And then I divide this by the moles of calcium sulfate, which we found was 0.00581. Okay, so this will be your value of x. So this is equals to, so when you punch this, what do you get? So let me punch it on my calculator. Okay, so you have 0.0116 divided by 0.00581. Okay, so when I punch this, I get 1.9965576.592. Okay, so round off this number, we are going to get what? 2. So it means our x here is what? 2. So for us to write the actual formula of this hydride, we're just going to replace this x here with a 2. That will be our actual formula. Okay, so we're going to replace this guy with a 2. So this one here is our what? Actual formula for the gypsum hydrate. Okay, so any questions there, guys? Any questions?
I want to ask you, is there any other formula other than using that for finding the value of x?
Yeah, there is, but the simplest one is this one here, because you can easily calculate the value of this, the moles of this and the moles of water. If you want, you can do a more ratio. Okay, you can do a more ratio. You can still find the 2 there. Okay. Right. So let's look at question 15 now. Okay, so question 15 was on I think percentage yield. Okay, so let's read. Okay, so here 15 they're saying ethylene oxide. Okay, ethylene oxide, which is this chemical formula, is made by the oxidation of ethylene, which is just C2H4. Okay, and they have given you the chemical formula here. I mean the chemical equation. Okay, so now the question comes, they're saying ethylene oxide is equal to ethylene glycol for automobiles antifreeze. Okay, then in a pilot study, 10.6 grams of ethylene gave 9.91 grams of ethylene what? Oxide. Okay, what is the percentage yield of ethylene what? Oxide. So how can we find the percentage yield? That's where the question starts. Okay, so the percentage yield is found by dividing the actual yield by the theoretical yield, and then you multiply by 100. I'm sure you know them. So let's write the formula here. So we are going to say percentage yield K is equals to actual yield divided by, okay, divided by the theoretical yield, okay, and then dividing by 100. I mean multiplying by 100. So theoretical here down, okay, theoretical yield, and then multiplied by what? 100. So this is the formula that we are going to use. So it means in our question, we just have to find the theoretical yield, and then we multiply by 100. Because the actual yield is the one that has been given here in the question. They're telling you that 10.6 grams of ethylene gave what? 9.91 grams of ethylene oxide. So meaning this 9.91, okay, is our what? Is our actual yield. So our job is to find the theoretical yield. So how are we going to find the theoretical yield? We're going to use more ratios from this what? Given equation. Okay, so let's get that equation and then we balance it. Okay, let's get that equation and then we balance it. So we have ethylene here, okay, which is being oxidized or reacting with oxygen to produce ethylene what? Oxide. Okay, so the first thing is to look at this chemical formula or chemical equation and then balance it. So we have 2C H4, 2C H4, and then here we have 2 oxygens, but here we have 1. So we have to balance that. So I'm going to put a 2 in front here so that I have 2 oxygen, 2 oxygen. But we notice that the number of carbons increased by 2, even the number of hydrogen increased by 2. We now have 4 carbons and 8 hydrogens. So what are we going to do to balance that? We're going to add a 2 here. Okay, so we've balanced this equation now. Okay, we've balanced this equation, and then we can use the mole ratio now to find the theoretical yield of this guy. Okay, so what have we been given in the question? We've been given that we have how many grams of ethylene? We have 10.6 grams of this guy here. Okay, so what we have to do here is find the moles of this guy. Okay, and then using that, the moles of this guy, we can find the moles of this guy. And then after finding the moles of this guy, we can use its moles and its molar mass to find the mass. So that mass will be our what? Our theoretical yield. Okay, so now let's find the molar mass of ethylene. Okay, so molar mass of ethylene. Okay, this will just be 2 multiplied by, what is the molar mass of carbon? Carbon is 12.01 according to the periodic table, and then plus we have 4 multiplied by molar mass of hydrogen, which is 1.01. Okay, so patch this onto your calculator, see what you're going to get as your molar mass. Okay. Okay, so I'm getting approximately, I'll just write 28.05 grams per mole as my molar mass of ethylene. Okay, I can also find in advance the molar mass of ethylene oxide, so this guy here, and then O. So it means we're just adding to the molar mass of this here, we're just adding oxygen, right? So we are adding 28.05 plus the molar mass of oxygen, which is what? 16. So what is the molar mass of ethylene oxide? Okay, we are going to get, what are we going to get now? Okay, I'm going to get 44.05 grams per mole. Okay, so now we have the molar mass of ethylene oxide. We also have the molar mass of ethylene, okay, and we have the mass of ethylene. So we can use this mass of ethylene and its molar mass to find the what? The moles of ethylene. So let's find here. So we are going to say moles of ethylene, okay, is equals to mass, okay, divided by the molar mass. So what is the mass? The mass is 10.6. And then the molar mass of this ethylene is what? 28.05. So I'm going to write 28.05 here. So this is equals to, punch on your calculator, what are you going to get? Okay, I'm getting 0.378 moles. So these are the moles of ethylene. Okay, and then now from that balanced chemical equation that we had, we know the ratio of what? Ethylene to ethylene oxide. So from this chemical equation here, we know that if I have 2 moles of ethylene, they are going to produce what? 2 moles of ethylene oxide. So here the ratio is 2 to 2, which is the same as 1 to 1. Okay, so if I have 1 more of this, it means I have 1 more of that. So it means the moles of ethylene and the moles of ethylene oxide, they are always equal, okay, since the mole ratio is 1 to 1. So since these are the moles of ethylene, okay, so you can write since the mole ratio is 1 to 1, okay, then even the moles of ethylene oxide will be the same as this. So we are going to write moles of ethylene oxide, okay, will be the same 0.378. Okay, so this will be equals to 0.378 moles. Okay, so these are the moles of ethylene oxide. Okay, so now once we have the moles of ethylene oxide, we know that we also found its molar mass, right? So we can use the moles and the molar mass to find the mass. So remember the formula: moles is equals to mass over what? Molar mass. So if we make this mass the subject of the formula, it means mass will just be equals to what? Moles multiplied by molar mass. Okay, so this will be equals to, what are the moles? The moles is 0.378 multiplied by, what was the molar mass of ethylene oxide? Let's check. Okay, the molar mass was 44.05. So you're going to write your 44.05 here, and then multiply on your calculator. Okay, so counter check with me, but according to my calculator, when I multiply that, I'm getting a 16, okay, 16.65 grams. Okay, so this mass here of ethylene oxide is my theoretical what? Yield. Why is it theoretical? Because I am obtaining it using what? Calculations. No wonder it's theoretical. So now we can go back to our formula for percentage yield. We had the actual yield given. We have found the theoretical yield. So we can just put them in the formula, and then we are off to go with our percentage yield. Okay, so we are going to write percentage yield here. Percentage yield is equals to, okay, the actual yield on top. So what was the actual yield? From the question, the actual yield was 9.91 divided by the theoretical that we found, which is 16.65. And then we multiply this by 100. So what are we going to get as our percentage yield? Okay, so punch on your calculators. Okay, so I'm getting 59 point, let me just round it off to one decimal place, 59.5%. Okay, so this here is my percentage what? Good. Okay, so any questions there, guys? Okay, no questions. All right, so now let's look at question 16. Okay, let's look at question 16 now. So question 16. Okay, what does question 16 have for us? Okay, so question 16 is this here. So they are saying okay, so question 16, they're saying okay, someone was asking I didn't use 2 when calculating the molar mass. Yes, so you don't use the ratios, that the numbers that you put in front, like 2 maybe oxygen like this. When calculating the molar mass here, you don't use this number in front. No, you can only use a number that is within the formula. Okay, so if I write K2 maybe SO4 like this, you can use this 2, you can use this 4. But if I put 5 like this, you don't use this number when calculating the molar mass. Okay, so I'm sure you've heard, you don't use a coefficient when you are calculating the molar mass. Okay, so now let's look at question number 16. They're saying consider the reaction of potassium hydroxide and sulfuric acid. So sulfuric acid is a very strong acid, and potassium hydroxide is also a strong base. Okay, so they're saying a reaction of potassium hydroxide and sulfuric acid to produce potassium sulfate and water. Okay, so they're saying if 25 grams of sulfuric acid is reacted with 7.7 grams of potassium hydroxide, determine 1, the limiting reactant or limiting reagent, and then 2, what is the mass of the sulfate produced, and then 3, they're saying calculate the mass of the excess reactant that remains after the reaction is completed. Okay, and then 4, they think calculate the theoretical yield. So this theoretical yield here is the same as this question. this question and this question, they are the same. Okay. Okay, so now let's come up with a chemical equation to see what is happening. So they're saying this is a reaction between sulfuric acid, okay, and potassium hydroxide. So potassium hydroxide is this guy, plus sulfuric acid, which is H2SO4, okay. This is producing what? It's producing potassium sulfate, okay, plus water. So first you look at this chemical equation, you notice that this chemical equation is not balanced, okay? It's not balanced. So what are we going to do in order to balance it? Because I can see 2K here, okay, but here I can see 1. So I'm going to put a 2 here, okay? So now the K is balanced, but what happens to the hydrogens? Okay, what happens to the hydrogens? I can see here I have 2 multiplied by this H, so I have 2 hydrogens there plus 2 hydrogens, so I have 4 hydrogens. Then on the other side, I have 2 hydrogens. So to balance the hydrogens, I'm going to add a 2 here. Okay, so we have 4 hydrogens. Even here we have 4. Then what about the oxygen? So the oxygen, I have 2 here, 2 oxygen plus 4. It gives me 6. And then even here, I have 4 oxygen plus 2 of the oxygen there. So it gives me 6. So the reaction is balanced, right? Okay. So what have you been given in this question? We've been given the mass of this guy, the potassium hydroxide. Okay. We've been given its mass as 7.7 grams. Okay. And then what else have we been given? We've been given the mass of the sulfuric acid, this guy here. Okay, so the mass of this guy, we've been given that it is what? 25 grams. Okay, so what will we need in this question? We'll need the molar mass of this guy. So molar mass of potassium hydroxide, we are just adding the molar mass of potassium plus water plus hydrogen. Okay. All right, so what is the molar mass of that now? So we are adding, for oxygen, it's 16, plus for hydrogen, it's 1.01, plus for potassium, is what? Is it 49 or something? Let me check the periodic table. Okay, let me just bring the periodic table here. Okay, so for potassium, what is the molar mass? It is 39.0983. Okay, so we can say 39.1. Okay, so plus 39.1. So when we add this, what are we getting as the molar mass of potassium hydroxide? Okay, so when I add all these, I'm getting, okay, because this plus this, it will be like a 40 plus that, it will be 56. Okay, so this will be 56.101 grams per mole. Okay, so this will be the molar mass of potassium hydroxide. What about the molar mass of hydrochloric acid? Sulfuric acid, not hydrochloric acid. So the molar mass of hydrochloric acid is well known to be around 98, okay, grams per mole. So if you want, you just get the mass of hydrogen multiplied by 2 plus the mass of sulfur plus the mass of oxygen multiplied by 4. You're going to get roughly a 98 grams per mole. Okay, so those are the things that we have. Okay, and then okay, yeah. So the first question there, they are saying find the limiting reagent. So how do we find the limiting reagent? Okay, how do we find the limiting reagent? We first have to calculate the moles of this guy, and then we also calculate the moles of this guy. So according to the balanced equation, we know that 2 moles of this guy needs 1 mole of this the sulfuric acid. Okay, 2 moles of potassium hydroxide needs 1 mole of sulfuric acid. So we'll compare those ratios to the moles that we are going to find, and then we'll be able to determine the limiting reagent. So let's calculate the moles of this guy. So we have the mass and the molar mass. So it means moles of KOH will just be equals to the mass, which is 7.7 divided by this 56 that we have, 0.101, okay? And then the moles of sulfuric acid will also follow the same pattern. Yes, someone has a question? Hello? Okay, I thought there was a question. So 25 divided by 98. Okay, so now let's punch these values onto the calculator and see what we are going to get. Okay, so let's start with the first one there, 7.7 divided by 56.101. How many moles are we getting? Okay, so according to my calculator, I'm getting 0.1375. I'll end there, moles. Okay, and then what are the moles of the other guy there? So 25 divided by 98. According to my calculator, I'm getting a 0.255 moles. Okay, so we see that in the reaction, we have this number of moles for potassium hydroxide, and we also have this number of moles for hydrochloric acid. Okay, but according to the balanced chemical equation, we know that 2 moles of potassium hydroxide need how many moles of sulfuric acid? 1 mole. Okay, so we can get any 1 moles of this. Either we get these, we put them here, and then we find how many moles they need of this, or we can get this, and then we find how many moles of the potassium hydroxide they need. Okay. Okay, let's say I get these moles here. So if I have 1, then I need 2. What about if I have 0.22 moles? 255 moles. How many moles of potassium hydroxide am I going to need? So cross multiply, it means X will just be equals to 2 multiplied by this number. Okay, so 2 multiplied by that number, I'm getting 0.51 moles. Okay, so it means that if I have this number of moles of sulfuric acid, then I need how many moles of potassium hydroxide? 0.51. Okay, but we notice that in the equation or in the reaction, we have 0.1375. So meaning we have insufficient moles of potassium hydroxide to react with all of the what? Hydrochloric acid. Okay, so what does that mean? It means the potassium hydroxide is insufficient. Okay, so meaning it is the what? The limiting reactant. Okay, so we are going to conclude here. We are going saying since, okay, that was 0.1375 moles of potassium hydroxide is less, okay, is less than the moles that we found for potassium hydroxide. This is 0.51 moles, okay, then the KOH is the limiting what? Reactant. Limiting reactant or limiting reagent. Okay, so any questions on how we have found the limiting reactant there? Any questions, guys? Okay, no question. Okay, so now let's look at the other question. Okay, so since this one is the limiting reactant here, it means it is the one that will determine how much product is what? Produced. So even in the follow-up questions, we are going to use the moles of this guy because it's the limiting reactant. Okay, so the next question now is, the next question they're saying calculate the mass of potassium sulfate that is produced. Okay, it means here we are going to use the mass of what? The potassium hydroxide, since it is the what? The limiting reactant. Okay, so The equation, remember how it is? It is like this. HKOH, okay? So if the video cuts, just join using the same link. I think I've written big things here. Okay, so remember the balanced equation is KOH plus H2SO4, and then this is producing K2SO4 plus what? 2H2O. Okay, and then we know the